Hello, friend! Yay! I'm so glad you could join me. We are going to learn what a logic gate is. But first, let's back up. Why do we need logic gates? Well, the world that you and I exist in is mostly composed of analog signals. And these look like waves, like woo, squiggle, 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 squiggle. That's a very thin line. Like that. That's an analog signal, or what an analog signal might look like. But computers use digital signals to transmit and encode information. And digital signals are either on or off, like this. They sometimes look like a square wave, so either on or off. And you might even erase those vertical lines like so. You're like, what are you drawing? I can't see. Analog, digital, where the low part of it is off or 0, and the high part is on or 1. So there are different ways to encode analog or continuous information, something that can be a signal from, it's not just on or off, it can be anything in between. And so logic gates are one way that we can take analog information and encode it into a digital signal. And then we can use that signal to transmit and store information with computers. Yay! All right, so how do logic gates work? Logic gates, well, there's kind of three main basic logic gates. We have the NOT logic gate, which is delightful, and it takes an input signal and it reverses it. So it turns it into the NOT of the input. So if you have an input signal that is off, the output of that logic gate will be on. Or if I draw it and I scoot this back, ooh, I can use the little eraser on here instead of my finger. Okay. We'll erase we'll erase parts of our signals and give us some space on this little cute board. So if I have an input coming in and my input is 0, the output will be 1 for the NOT gate, like this. Ta-da! What do you think it will be if the input is 1? What do you think the output will be? Yeah, exactly, 0. And since we're dealing with digital signals, we only have 2 possibilities. So that's it. That's what the NOT gate does. I'm not going to use, I am going to use push buttons instead of transistors to build these representative logic gates because it's a little bit faster and it's also a little bit easier to see what's going on. I'm going to skip, well, I guess I could build a NOT gate. The NOT gate does something, this push button doesn't want to fit on my little board. Its legs got a little bent, which happens sometimes to the best of us. But a NOT gate built with push buttons is a little bit sneaky in the sense that it's kind of just short-circuiting. So let's build a logic gate together. And our circuit will need 3 main things for this to work. It will need a power source, my little coin cell. Let's see if this is on. Nope, it is off. Now it is on. We will also need something to help us see the electricity or engage with the electricity. So we're going to use a little green LED. Okay. And we need wires to transmit that energy. Since we're building a logic gate, we are also going to use something to build that logic gate. Yes, yes, yes. Okay, so our NOT gate is going to flip the signal. And so bear with me because it's actually been a hot second since I have built these. But we can think about it, right? Oh, what? Why did that not work? Oh, because, no? What? Excuse me, please. Oh, there we go. Okay, sometimes wires, electricity. Yep. Breadboards, good times. Okay, so let's think about it. We need our push button to reverse the signal to the LED, the little light from the battery. And so what we want to do is we want to kind of give the electricity an easier path to flow through the push button when we press it down, because electricity is lazy. So what we're going to do is we're actually just going to make 2 parallel loops to the battery, or sorry, from the battery to the push button and the LED. So that when I push the button, when I push the button, there we go. Okay. Do. Okay, I think my push button's not totally connected here. Oh no, that's not supposed to happen. Come back, please. Oh, one of these wires is all funky bits. A bunch of these wires are all funky bits. There we go. Okay, that's a little better. Okay, so when I push the button, it flips the signal from the battery to the LED. Well, flips. We're going to put that in quotes because it doesn't really. It's actually just making a short circuit. So right now, the electricity is traveling from the positive side of the battery through this red wire into the positive side of the LED, out the negative side of the LED, and back to the battery. And when I press the button, the electricity has an easier path to flow through one leg of the push button, through the metal kind of bubble inside. And when I press it down, that bubble connects the other leg of the push button, and so the electricity can flow from one leg through that bubble and out the other side and back to the battery. Electricity wants to be lazy, easier to flow through the button than through the LED, and so it skips the LED when I press it down. And so now the signal, even though the battery, well, yeah, so now it flips the signal. Oh, and it releases. Funny. Cool. So we built our simple NOT gate. Also, I realize it might be a little small for you, so here's a close-up of our NOT gate. The pieces are very far away. So this is where the push button is shorting the electricity or giving it an easier path to flow instead of through the LED. So I push this down, it goes off. Oh! But well, I guess that's kind of what we want. So there we go. There are 2 other push button logic gates. The basic logic gates, I should say. There are lots and lots of logic gates that you can build. My favorite's the XOR gate. Yay! Turns out it's also the basis of binary calculators. Da, 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 da. If you're curious to find that out, you can check out my book. That thing. Or you can ask me. I can give you more information. So the AND gate and the OR gate. And since we are at 8 minutes, I recognize that some of y'all might be like, okay, I'm done. My brain is done. Totally get it. So let's build those in the next video and you can take a little break. See you next time. Bye.